investigations into vehicle fuel filtration devices and their impact on fuel efficiency, the environment, and the economy. Title of purpose. This project was chosen to explore the long-term effectiveness of a vehicle's fuel filter and determine whether an old, exhausted fuel filter is a factor that contributes to poor fuel efficiency and therefore reduced fuel economy. The experimental question states, is a vehicle's fuel filter a contributing factor to improved fuel economy/efficiency? And how does this relate to the preservation of our natural resources, atmosphere, and the economy? The hypothesis states, if a vehicle's old fuel filter is replaced, then a vehicle's fuel economy/efficiency will be increased because clogged filters are sources of decreased efficiency in a fuel system. Research. Research Part 1. Birth of the internal combustion engine. In the late 1800s, the need for an improved form of transportation arose. Many believed the solution would come in the form of an engine. The plans for the engine called for three components: compressed air, fuel, and a spark. In 1879, German Carl Benz was the first to perfect the design. He patented the engine, and it became the first internal combustion engine to be used in the production of publicly available motor cars. Since Benz's invention over 140 years ago, auto manufacturers have continued to expand on his design. Research Part 2. Fuel. Fuel is an essential component to an engine. Fuel is defined as a material used to produce heat or power by burning. In the case of an engine, fuel refers to gasoline. Gasoline is a fuel mixture of petroleum liquids and crude oil. Gasoline is produced using a process called fractional distillation. Crude oil extracted from the ground is vaporized and then cooled to form new liquids called distillates. One of these distillates is gasoline. Many fuel refineries add chemical additives to the gasoline to increase combustion potential and reduce harmful emissions. Gasoline is then sent to automotive service stations, where it can be purchased by consumers. Research Part 3. Fuel statistics. First discovered in 1859, fuel was regarded as unnecessary at first, until the widespread use of Benz's motor car. By 1900, around 9 million motor cars were all in use, all with gasoline as their main fuel. By as late as 2014, 1.2 billion vehicles were estimated to be on the roads in the U.S., with 2 billion predicted by 2035. An estimated 1.7 billion tons of greenhouse gases, mostly carbon dioxide, were produced by vehicles in 2019. 142.71 billion gallons of gasoline are consumed by the United States every year. 9.31 million barrels of gasoline are consumed per day, and with each barrel costing $50 to $70, roughly $170 to $238 billion are spent on gasoline in the U.S. every year. Research Part 3 continued. Green New Deal and Change in the World. Introduced in 2007 by Pulitzer Prize winner Thomas Friedman, the deal proposes a plan to eventually eradicate all harmful emissions and convert all U.S. transportation to all-electric by 2030. This signifies the elimination of all gas-burning machines used in businesses, houses, and most significantly, in light of this project, vehicles. Much time remains before this feat is accomplished, however, and in this time, efforts must be made to make vehicles as efficient as possible to comply with evolving standards. But how? Research Part 4. Fuel efficiency/economy. Fuel efficiency is defined as a measure of how much energy is produced in relation to the amount of fuel that is burned. Fuel economy, on the other hand, is a quantifiable rating of miles traveled per gallon, miles per gallon. Any slight improvement in the U.S. fuel efficiency as a whole could have a major economical impact. Cutting fuel usage from 390 million to 290 million gallons of fuel per day could result in savings of up to $400 million per day. This would result in $1.46 billion per year of savings on gasoline in the United States. This figure is achievable by each American saving as few as 1.4 gallons of fuel per day. Research Part 5. Vehicle Fuel System. Overview and Application. What is a fuel filter? First invented in 1960 by Milton J. Kittler of Holly Carburetor Co. in Van Dyke, Michigan, a fuel filter is a metallic cylinder filled with cellulose or synthetic fiber pleats. Fuel filters are essential for filtration of contaminants found in fuel. Modern fuel filters effectively strain 99% of particles as small as 2 to 3 micrometers. Why is a fuel filter necessary, and how does it relate to fuel efficiency? A fuel filter is absolutely essential in order to prevent contaminants from reaching the engine. Small particles not filtered out can clog fuel injectors. Clogged injectors can starve the engine of gasoline, causing the engine control module to send for more fuel. This causes strain on the fuel pump, which can lead to pump failure. The engine cannot burn the excess fuel as efficiently, leading to a decrease in fuel efficiency, and in turn, fuel economy. The excess fuel leads to poor engine performance and potential for complete engine failure. Research Part 6: Fuel Filter Replacement plus Benefits. What are the benefits of replacing the fuel filter? Replacing the fuel filter eliminates reduced fuel efficiency and economy, and has the potential to save up to $1,000 on gasoline for vehicles kept over 10 years. Replacing the fuel filter also reduces the risk for catastrophic and costly vehicle component failure. It also has the potential to save the U.S. exponentially on gasoline prices, which will in turn reduce negative impact on the economy and the environment. Experimental setup. Research and preparation. Research was begun in October of 2020. The area of automotive engineering was chosen based on a personal hobby of automotive care. The topic was chosen after forming a hypothesis based on personal plans to conduct vehicle maintenance regarding the fuel filter. A two-part project was chosen. Part 1 consisted of replacing the fuel filter and subsequent tests/recording of fuel economy before and after on real-world vehicles. Part 2 consisted of individual tests on one new and one old fuel filter to determine possible areas of decreased efficiency over time and differences in filtration characteristics based on age. Experimental Research Part 1: Vehicle Maintenance. Planning was done months in advance to collect and record data. 2 test vehicles with old fuel filters trip odometers were reset to 0 miles after a full fill-up with gasoline. Over the next weeks, fuel was consumed. At the next fill-up, the number of miles on the trip odometers were divided by the number of gallons in the fuel tank. This quotient yielded the effective miles per gallon achievable by the vehicle. This process was repeated multiple times to ensure the most accurate data. After this, the vehicle's fuel filter was replaced, and the process was repeated again to acquire new fuel economy data after the replacement. Experimental Setup Part 2: Tests with filters of varying age. First, I began by cutting open the fuel filters I had purchased. Care was taken to prevent as much sparking as possible, in the event that any gasoline remained in the filters. Once opened, the condition of the new and old filters were recorded. The weights of the respective filters were also recorded. Qualitative data was recorded based on each of the filters. Samples of new and old fuels were also collected, with the old fuel being collected from inside the old filter after it was taken out of the vehicle. The old fuel is beyond recognition, with potentially 17 years of contaminants trapped within it, as shown in the picture below. In the top left picture, a new fuel filter is shown. In the bottom right, an old fuel filter. After cutting open the filters, a rig was built to support them vertically. This allowed reservoirs to be placed atop and fuel to be passed through to containers underneath. I then began my experimentation after forming a secondary hypothesis, based on my overarching hypothesis. My secondary hypothesis states, if gasoline is passed through a new and an old filter, then fuel will pass more quickly through the new filter, because years of contaminants will hinder flow of fuel through the old filter. I began experimentation by dividing gasoline into plastic cups and weighing them so that they were held constant. I then proceeded to pour gasoline into the top reservoir of the rig and let it flow through to the container on the bottom. I timed this trial for both the old and the new filter. This process was repeated a multitude of times. Trials were repeated in many different iterations. Sand was added to samples of gasoline to determine whether the filter would separate it out. Old samples of fuel were passed through full of contaminants to see if the filters would filter it out. The contaminant-full gasoline passed much slower through the new filter than the new gasoline. The new filter was then cleaned to absorb what it had caught. Data tables, charts, and graphs. Shown below are the two graphs for the first part of the experiment. Over a period of roughly 4 weeks, 4 trials were completed, allowing a tank of gas to be used completely, and estimating the number of miles achievable. This was then compared to data taken after the fuel filter was replaced. The 4 trials were independent, but graphed together to show fluctuations over iterations. The y-axis signifies the total number of miles traveled per tank of gas for each vehicle, 14.5 and 16.5 gallons respectively. Average trend line indicates average miles traveled per tank of gas before and after the replacement of the fuel filter. Outliers in data for individual trials may have arisen from prolonged trips on a tank at high speeds. An estimated 1.5 mile per gallon increase is visible in Vehicle 1 and a 2 mile per gallon increase for Vehicle 2. This graph signifies the second part of the experiment, in which clean fuel was poured through new and old fuel filters. Fuel was hypothesized to pass more quickly through the new fuel filter. The data, however, shows that on average the opposite is true. The trend lines indicate the speed at which the fuel passed through each filter, respectively. Fuel may have passed more quickly through the old filter due to its age. The age may have led to the degradation of the filtration characteristics. More trials were completed in different iterations. 2 trials were completed using very old contaminated fuel, shown to the right. The old fuel took significantly more time to pass through the new filter. Not enough data points were collected to draw a conclusion based on this trial. However, the old fuel may have passed through the new filter more slowly because of the increased filtration characteristics of the new fuel filter. Conclusions. Conclusions Part 1. Several conclusions can be drawn from the first part of the experiment. The filter replacement resulted in a very small but potentially significant increase in fuel economy. These trials were completed more than one time to ensure no outliers were present, and then taken average. These average results prove the hypothesis correct in its statement that a vehicle's fuel efficiency will increase with the replacement of an exhausted filter. This replacement does in fact have the potential to save the vehicle's owner on gasoline and eventual repairs based on failed parts. This vehicle maintenance will not only save the vehicle owner costs, but will, in time, have an exponential impact on the U.S. economy on the basis of fuel expenditure. The small savings of gasoline by individual citizens and businesses, therefore, will also reduce negative impact on the environment by reducing harmful emissions and the burning of excess fuel. Conclusions Part 2. A few conclusions can also be drawn from the second part of the experiment. Fuel passed through the 2 filters at very similar speeds, regardless of age of filter or contaminants within. This proves the hypothesis incorrect in its statement that gasoline will flow at a much slower rate through the old filter in comparison to the new filter. However, old gasoline full of contaminants passed at a much slower rate through the new filter. This observation does not negate the benefits of replacing an old filter. There are many possible reasons that led to this outcome. The old filter may have degraded with age to a point where it allowed too much fuel to flow through without filtration. Both filters were effective in filtering sand, and after many trials, small amounts of contaminants could be observed after evaporation of gasoline.